What is this? What chapters are going to be on this test? And everybody's aware the test is Monday. Monday. 4, 5, 6, 7. Sounds like a lot, but remember they each had like 2 sections. 4 was the x, p of x stuff, and the binomial, the NPQ stuff. 5 was uniform probability. 6 was normal. And 7 was change the standard deviation. Oh shit. Alright, so the formulas. Let's see if nobody loses points this time with the formula sheet. That'd be awesome. You have this little dude, right? When do I use that formula? Probably when I give you x's and p of x's. That's a huge trigger. What is this the formula for? Variance, 11. So if you want to, you don't have to write this next one. It's the same thing. You can write this for yourself. Just to remind yourself you better freaking take a square root. Don't forget that square, that mu. And then the other stuff from chapter 4 was the binomial stuff. And you have its mean, its standard deviation, gas. So that's chapter 4. Chapter 5, there's no formulas from chapter 5. I told you the mean and standard deviation for uniform. You're going to see it in the homework, but I'm not going to test you on it. I just want you to know it's out there. And then chapter 6, it's not a new formula, but you have this dude, which leads to this dude. And then chapter 7, you've got this little dude. And if you want to, this just looks disgusting as all shit, but if you really, really want to, if I were you, I wouldn't. The formula for z-score never changes. It's the data point I'm interested in minus the mean divided by the spread. If I take a sample, I'm talking about the sample mean, that's the point I'm interested in. I'm talking about the mean of the means, which is the same anyway, divided by the new spread, which I'd calculate anyway. The formula doesn't change. But if you want to, and you don't think it's going to confuse you, you can put that formula down too. It's the same stupid formula. Okay? So you can't get through this class by memorizing everything you're supposed to do. That's insanity. It has to make sense. And it's not impossible for it to make sense because we made this shit up as a human race. So we have to be able to make sense of it. So if you try to memorize everything about when to do what, oh my God, I feel bad for you. Anything else? Any other suggestions on? Did I miss anybody? Anything? Any formulas? How you guys doing? You all right? Holy shit. Okay. All right. So, all right. You're physically here. This is good. This is half of the problem. Most of you are physically. Okay. So, if there's nothing else you want to put on there, if somebody comes up with something on the test day and I'm like, oh yeah, I'll put it up on the board or something. But, you know, if you have suggestions for other things for the formula sheet, you can bring all of your formula sheets in. Probably don't bring them in if you lost points on them. Probably rewrite those. But you can continue to bring all your formula sheets in. You can put them on poster board. I don't care. As long as you don't bother people around you. Okay? You don't have to put them on a tiny little piece of paper. And I'll sit up here laughing at you. Okay. So you guys, we could look at the practice test, as always. We could look at homework problems. We could look at the quiz. Right? There's another quiz before this one. The corrections are due on Monday. Yes?
Can you correct phrase 5?
Oh, no. Yeah, if you have extra notes on stuff, like your formula sheet or the Z-squared chart, you just lost those. I'm sorry. What happened? Yeah, of course you can correct. But that's not your question. You're asking what's the idea?
Yeah.
Okay, all right. I thought you were asking, can you correct it? I'm like, shit, yeah. Okay. This is not on the formula sheet. I'm going to leave this up here for right now. It just came in. That's your formula sheet for the test. Let me know if you have another formula you want to suggest to put up there. What does uniform distribution look like? So I made the uniform problems worth 6 points each, and then the next two were worth 12, and then the last two were worth 16 each. So I made the uniform worth less, but my God, we should know how to do uniform probability. What's it look like? What shape? Rectangle. And since the probabilities are related to areas, uniform probabilities should be easy. Areas of rectangles. We don't seem to really get that. So if I had a uniform thing from 10 to 22, so it's going to look like a big rectangle that goes from 10 to 22. So how tall is it going to have to be? Because how wide is it?
1 over 12.
Yeah, it's 12 wide. And all the probabilities should come out to be 1. So if this is 12, this is 1/12. If this was 17, this is 1/17. It's not 1 over 22. It's not 1 over 22. It don't make no damn sense. It doesn't go from 0 to 22. It goes from 10 to 22. So it's 1 over the width. Because what do you multiply by to get 1? The reciprocal. I want to force the total area to be 1. So now any question I ask about an area, about probability between two things, is just finding the area, which is exactly what we do with normal distributions, right? In that chart, that's just areas in that curve. It's just, I can't use geometry for that shit because it's curving. Okay, it's the same idea. It's just nowhere near as easy because it's not a nice shape. So if I ask you, what's probably that, I get something between, make it in there, yeah, 15 and 17. So if you draw that, it looks like 15 to 17. So what's the area of that rectangle going to be? What's the area of any, what's the height of any rectangle in there? 1/12. That's the height. So all I got to know is the width of any little rectangle I'm talking about, and multiply then, that's the area, which is the probability. So how wide is this thing? 2. So what's the area of this thing? 2 times 1/12. 1/6, 16.66%. 66666. .16667, whatever the hell you want to put down there. Is that cool? Now, here's the question, Grady, you're finally going to catch up to you. What's the probability I get something less than 10? 0, done. What's the only things that could happen in this situation? Things that are from 10 to 20. So what's the probability I get something less than 10? 0. What's probably I roll a normal die and I get -3? 0% chance of happening. Not -3/12. Right? It's not going to happen. This is 0% because it's not in the realm of what could happen. If I have 8 people, what's the probability that 9 of them understand probability? 0%. There's only 8 people. How in the world are you going to get 9 of them? It's freaky. Yes?
When we draw the rectangles, should we give a space?
Yeah, pretty much, unless it's 0. I mean, it's a normal scale on a normal XY thing, so it's just like histograms. There should be a little space unless it's 0. Yeah. Just to remind you that it isn't 22, it's this. It's 12, yeah. It's not 22 that we're dealing with, it's 12 we're dealing with, the width of it, yeah. I like it. Okay. Anything else we want to talk about? I want you to really, really understand something. If you don't understand something, there are at least 8 other people that also don't understand that thing. You cannot believe me as much as you want to, but it's true. It's just true. So I know a lot of you guys are sitting there like, I don't want to ask because I'm stupid and I don't know. That's insane. That's silly. So ask anything. What is it that doesn't make sense? Oh, all right. One person got 2 extra points on that. I was given 1 point or 2 points. If you said the probability, blah, blah. So, like, if your question was, if 3A was probability X greater than 70, and you got 0.1239 or something, right? Just pretend like that's what it was. Whatever your situation is, you can apply it to your situation. What exactly does that mean? That means you could say that there's a 12.39% chance that somebody scored higher than a 70. Okay, you got a point for that. 12.39% of the class got a score higher than 70. Ah, there you go. That's really what it means. I like it. Does that make sense?
But if you say of the grades in that class, it's not the same as the whole class. And I got 1 point. It's not that I'm.
Oh, okay, okay. Well, that might have been my mistake. You
Like,
show me. You can show me. I meant to give 2 points for this. I gave you 1 point. That's my mistake.
it's- And should we circle the answer? I mean, it's like a continuous. Like
Yeah, especially when it's in the middle of stuff.
Okay.
Yeah. I mean, as a, you always box off that answer. Don't box off anything that isn't the answer, because I'm like, oh, shit. Yes?
Can you go over the fourth one?
Which one? Sorry?
The fourth one?
This dude.
Yeah.
Okay, you want to do an example with it? Okay, all right. So hopefully everybody's got those formulas down, if you wanted them. Because I'm going to take them away now. All right. So let's say that 82% of Americans I don't know, don't want to have Trump text them. Okay. I have my phone set up in such a way that I didn't get that text. You guys get that text a while back, the little text? I didn't. I'm like, whatever that setting is, I'm not going to change it. I don't want this man texting me. I'm sorry. All right. And we pick 22 Americans at random. Everybody with me so far? So how can you tell? I call it an NPQ problem. You should be identifying an N
Wait.
a P, and then there must be a Q. There must be a not this. There's a this and a not this. 11% left-handed. So then therefore 89% not left-handed. You know, it should be a little obvious that a problem you're looking at is an NPQ problem. Because you can identify N and P and then figure out what Q is. So far what do I know? N is 22, P is 22, so Q is 0.18. Because what do P and Q have to make together? 100%. I like it. So now let's say what's the probability that we get exactly 17 of them? So I picked 22 Americans at random. What's the probability I get exactly 17 that don't want texts from Trump? So in this case, what is the 17? Well, it's X. That was really nice there. I told you that. So now you just throw it in the formula. Now, there's a formula. It's just plug and chug. I hope you were here and it made sense where the formula came from. It's almost too nice to believe that I can read math formulas as sentences. It really is just another language, right? I can take a book written in Romanian and translate it to English and read it. So I can take this formula, that's like Romanian, or maybe in Greek, so Greek to me. But I got so many people choose this many to be a success. So this many successes, the rest are failures. I mean, that's so, yes.
How should we feel?
Oh, all right. If P is the probability of success, and that's 82%, what must the probability of failure be? The rest.
Okay.
So P and Q always make 1 or 100% as a percentage. So if you know P, you have to know Q. And what's true about P and Q? Can any of them be bigger than 1? So if you're writing something bigger than 1 down for one of these, you are doing something wrong. You're going to some funky answers. Okay. So now it's really just plug and chug, but married with why it makes sense, hopefully. So I want 17 successes. So I got 22 people. Choose 17 of them to be a success. Remember what this number told us? It told us how long the list would be if I made it. I don't want to make this. Do 22, choose 17 in your calculator. It's going to be a lot. I don't want to make a list that long. How many successes do I have then?
82.
Well, 82% chance. How many of them? 17. So how many of the other stuff?
0.18.
How many of the other stuff?
5.
5, because I got 22 total. If there's 17 of these, there has to be 5 of these. Please let that make sense. Don't go, well, it's math. It's not supposed to make sense. It's not allowed to make sense. Actually, math makes sense. So much of what we do in this class, I've tried to tell you, makes physical sense. It makes sense. I mean, now, don't get me wrong. Not everything in here makes immediate sense. I understand that. But you can make sense out of how we got to what we do. Yes. And now you just throw that in the calculator. How do you get to this dude? Yeah, it'd be 22. Math, probability, and then it's the third option, I think, right? NCR. So those are all buttons you push, right? That's the one of the few things I let you just let the calculator do. 17 times 0.82 to the 17 times 0.18 to the 5th. Let's all try that out. I didn't bring calculators, so if you don't have one, just do that in your head. I got a number. I don't know. Looks like it might be right. What'd you guys get? Anybody want to tell me? Anybody else get? 05. Yeah, so you get point. Yeah, Jeff. 0.1705. Say again?
What decimal place do you round to?
For probabilities go how many places? 4. Why did I start doing that way back when? Because the z-score chart takes it out to 4, and I want you to get used to it. 4 is decent because then if you make it a percentage, it's 2 places on the percentage. That's a decent accuracy. Now, if you know binomial, PDF, CDF, that kind of stuff, that's great. You could put it in your calculator. I better see this freaking formula set up. What I love it is when this is wrong, but then the answer is right. It's always neat. Make sure you understand how to set this up. Set this up. I don't care what you do after that. Yes?
Can you do one like the probability that x is less than 20?
Yeah, so let's do it like with this. Okay. Oh, gosh. Poor little dude. Let's try you out. Yeah, let's do x is less than 20. All right, take it easy. What happened back there? So what does that mean? X less than 20, what does that mean?
Probability x equals 21, I think.
But what's x less than 20 mean by itself? It means you could have 0, 1, 2, 3. So you'd have to do a formula for every one of that up to 19. What's the opposite of x less than 20 for this problem?
1 minus that.
No, the opposite is,
X.
More or equal to 20.
yeah. And how many things are more or equal to 20 in this problem? 20? 21? 22, because you can't have 23 people when you have 22. All right. So I have either 20 calculations to make or 3 calculations to make. I'm going to choose 3. You could choose 20 if you want. It's up to you. That's the power of the 1 minus. If the opposite situation has less work to do, I calculate it. That's the opposite of what they want. So then I do 1 minus what I get. That's what they want. Because that's how I make a probability the opposite. So this means I have to do probability x equals 20, probability x equals 21, probability x equals 22. So you get 22, choose 20, 0.82 to 20. Is that, do you guys? And then you do it for 21, 22. You would add those. That's the answer to this. And you 1 minus that to get the answer that they want. So when do I do that? When the opposite situation has less work to do. So I don't look at it like, I got to memorize that. I look at it like, oh, good, there's a way to do less work. Oh, good. Binomial CDF, don't just tell me what you pushed in the calculator. Again, that's not going to work. I don't care what your past teacher lets you do. I don't care what the book says. The book and me together make the class, and I told you how to do these problems. Yes?
So for, as you said, we will not use the formula for the mean standard deviation.
For the uniform.
But
That's right.
in the practice test.
Totally, all day long. Because what can you use on the practice test? Everything. Your notes,
Okay.
everything.
I just wanted to.
I'm with you. But the real reason I did that on the last one is to show you I don't care what the distribution is to begin with. I don't care what it is. It could be binomial, it could be uniform, it could be whatever. What do I do when I take a sample and I ask about the sample mean? I change the standard deviation, right? So on that last problem on the practice test, you calculate the standard deviation using that weird ass divided by 12 thing. But then for the last question, you have to divide that by square root of 43 because I got to make it the standard deviation for groups of 43. I like it. That's why I wanted to put that on there. It doesn't matter where the standard deviation comes from, what distribution it is. If I take a sample, I've got to change it. Yeah. Oh my God. That heat better turn off. Or is it just me? I don't know. Is it warm? It's warm. All right. I can't control it, of course. It's fantastic. Number 2? Is that what it is? Okay. Number 2 is an exercise in, do you understand the z-score chart? Right? So it's, so I tell you, you have a standard normal curve. The standard part of that tells you it's z-score stuff. And then the questions tell you it's z-score stuff. So if I know it's normally distributed, and my questions are all probably z less than 1.11 or something, what goes in the middle of my picture?
0.
Why?
That's the z-score.
Yeah, my picture's going to be z-scores. How far is the mean away from itself? 0, right? Please let that make sense. Z-scores are the distance from the mean. So what's a z-score for the mean?
0.
0, right? If I had like a D score for how far I am from my house, I'm at my house. So the z-score is 0, right? Okay. Some of you guys are putting, I love it. Some of you guys actually put a 0 here, and then you put like a 1.9 there and a 2.4 there. I'm like, think for a second. What's wrong with that? Not even that it's not related to the question right now, but just
Because it's before.
1.9 is not less than 0. So your picture, thank God, your picture is supposed to help you. But if you don't draw it correctly, it's not going to help you. All right, so for this problem, what am I going to put up here and where?
Negative 1 is.
All I care about is 1.11.
Oh.
That's all I care about. And where's it going to be? And it's asking for the area where?
To the left.
To the left.
Yeah, below it. I like it. So I think on this one it's negative 0.52 to the left, so it would look like this. So for part A, it's probably z less than negative 0.52. So there's 0. There's negative 0.52, so I want that area. Why is that nice? What does the chart tell you? It tells you the area below the z-score I look up. I like it. So I don't have to do 1 minus. I just look it up and I'm done because the chart tells me the area below. So when do I have to do freaky shit? When do I have to do 1 minus or subtract 2? When it's greater than or when it's between 2. When the question isn't the probability less than something. Because then it isn't what the chart tells me. I got to adjust it. All right, so here you just look up negative 0.5, negative 0.5, 02, negative 0.52, and whatever that number is, that's the answer. So can you find it? Take a look for it? How are we doing so far? No? You asked this question, right? Or was it somebody else? Did I forget? Who asked this question? You? Okay, I'm sorry. You asked an earlier question. Is that good so far? Yeah, so if you look up negative 0.52, so you got to go past 0, 1, 02. Bam! What do you guys get?
0.3015.
3015?
Yeah.
Okay. Is that what I got? Yeah, that's what I got. Can you find that? If you cannot find that, call me over. Don't give a shit if somebody else thinks, oh man, they're dumb. Who cares about what other people think? If you can't find that now, you want to be able to find it for the test. Is everybody able to find that number? Okay. Yes? Okay. So, real quick, when would I have to do 1 minus the 0.3015? If the question would have been greater than. So if the question would have been z greater than negative 0.52, my picture would have looked like this with an area up here. And when I look up in the z-score chart, you immediately put it on your picture below what you just looked up so you don't mess up. Why? Because that's what the chart tells me. So I would put 0.3015 here, and I'd go, did I get the answer? Oh, no. Past me was nice. They shaded that part of the thing in, so I remember that's not the answer. It's got to be there. And quite a few people, I love you guys, quite a few people were like 0.98. 98% is in that little, holy shit. That's like if everybody in the U.S. moved to Vermont or something. 98% isn't in there. It's on this side. So that would be 2%. That makes visual sense. That's what the picture is supposed to do. It's supposed to help you make sense of what the answer should be so you know when you made a mistake. So sorry, I cut somebody off. Who was about to ask a question?
It's a different problem.
Okay.
We do 1C, the probability x is greater than 1.
Oh, yeah. So on the practice test, it's -1, 3, blah, 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 right? So the probability x is greater than 2. Well, what does x greater than 2 leave out? No, there's no 2 here. What data does x greater than 2 leave out?
Everything except for -1.
No, so it leaves out -1. So you could, greater than 2 would be 3 and up, so you could add all this shit together. Really, but what do all these add up to be? 1. So 1 minus this is this. I don't care which way you do it. Just the 1 minus thing is a nice, tiny little shortcut. So you either add up all these, because they're all greater than 2, or you do 1 minus whatever the hell this is, because they all add to 1. So of course 1 minus that piece is the other piece. If I told you this piece of wood was 1 foot long, and I told you this is 0.2 feet long, how long is this? 0.8 feet long, right? 1. So if the whole thing is 1, and I want to know how much this is, I do 1 minus this. Or not. I just add all these things up. Where'd it go? Add all these up, I get the answer. Greater than 2 means all these things. That's fine. Either way, you get the right answer. Yeah, okay. Yes?
You've mentioned a couple of times about the z-score. If it's not a normal, if it's not normally distributed, we cannot use the chart. Can you repeat that? Can you repeat about the z-score?
Oh, sure. If it's not
When to
normal,
use
you
the
can't
chart?
use... I'm sorry,
Yeah.
I'm being a jackass. So the chart is built off of this picture. Those numbers require it to be perfectly normal.
And you said if the sample is not large enough, we cannot use the chart.
Exactly. So if I don't... So when do you know you can use a chart to look up probabilities? Either I tell you it's normal, or the sample is more than 30. That's the magic number. If I don't tell you it's normal and I took a sample of size 11, you can officially say, I can't do this. Right? Now, if you think, now trust me, I'm not going to let that happen. Because can you imagine how evil that would be? You don't notice that, you do all this work and you wasted all that time. I am not going to do that. So if you think that's a situation, write down, I don't think this is normal, but here's what the answer is if it is normal, and do it. Trust me. I'm not going to give you a problem where I'm like, if they don't notice, they're going to do a lot more work. I mean, how evil. I know you think math teachers are evil, but I'm not, maybe in 10 more years. 10 years ago I said that. I'm still not that evil. I am evil, I'm just not that. Does that make sense? That you guys with me? I mean, when can you calculate a z-score? Anytime. Anytime you have a mean and a standard, you can calculate a z-score. But when can you turn it into a specific percentage of probability is if I know it's normally distributed. Or I know what the shape is. If it's uniform, then bam, I can do that all day long. Just get areas of rectangles.
How do we find like the bounding middle?
Oh, okay. I like it. First step is, can you draw the picture? So this one was the middle 91%. So let me get you started. So middle 91%. Can you just take a minute and try to draw it? If you already did. This is a problem on the practice test, number 3, the second part. I want the middle 91%. Can you draw that? So it's going to be like this, man. So this is the middle 91%. Nice big chunk right in the middle, right? The heartland. So do you remember, just for a minute, give me a second, box plots and how the box was the middle 50%? So there's this whole idea of the middle chunk, the heartland, the cut out the extremities, right? Talk about what the most people or most grades are in here, that kind of idea. Chapter 8 is going to be huge on this idea. So how the shit do I find those z-scores? Does the chart understand this area at all? What's the only areas that the chart understands? Because I told you this is normal, right? That's why I drew this. But what's the only areas that the chart understands? The area below a z-score. Well, what z-scores do I want? I want this one, and I want this one. Now, what's true since it's symmetric? If this is -2, this is there. So I can focus on getting this dude. In order to look up this z-score, I need to know the area below it. Well, that's 91%. How much is outside? How much is outside total? 9%. So how much is on one side? 4.5. So this must be 0.045. You guys see how I got that? 91% in the middle means there's 9% on the outsides, means there's 4.5% on each side. Why do I need that? Because the chart only understands areas below a z-score. I want this z-score right here. I want it. Doesn't it have that much below it? Of course it does. So I can look that up in the chart to get that z-score. Go ahead and try to do that. Yes?
The 0.045 percentage changes.
Totally, yes. So 91% in the middle, 9% outside, 4.5% on that side, and that's 0.045. Because the chart's all in decimals. Yeah. What are you guys getting? Are you trying it out?
-1.7.
-1.7 should be the closest. I think it's 0.0446 or something.
It's 0.045 actually.
No. I mean on the chart. I think it's 0.0446. It's the closest you can get to 0.045, and that's -1.70. Now take a minute. Make sure. Please, I know that a lot of you guys don't believe me. But if you don't understand where that number came from, there's at least 8 other people that also don't. Is everybody able to see how that number was gotten? No, okay. Can somebody, let me borrow, I gave away all my, shoot. A lot of people have to be so good and make it so hard.
So that's not 0.045 is a negative because it's a z-score.
So this z-score is below the mean, so I know it's going to be negative. Plus 0.045 has to be on the negative side because the other side starts at 0.5. Who's going to be borrowing there? wake up someday, maybe. Just turn on. Poor little dude. Okay. All right. So, how do I normally use this chart? I normally use this chart by looking at z-score up here and then looking on the inside for the area. So, that is a reversible process. A lot of math is all about reverse. Algebra is all about backwards. Right? I don't know how much money I put in the bank, but I know I got $4,000 in interest. It's like, who are you? But then you got to work backwards. Okay. So this, if I normally look up a z-score and get an area on the inside, I should be able to look up an area on the inside and look outside and get the z-score. That's the idea. So here I got an area, 0.045. What's the closest I can get to the area in here? So it's either one of these two, right? Which one of those is closer to 0.045? Some people will say this one because it's got 0.045. Isn't that 5 away and that's only 4 away? You guys see that? So the answer is negative 1.70. For that one, what's the other one? Positive 1.70. There you go. That's the complete answer, is those two. So if I know that I've got between negative 1.7 and 1.7 z-score, that means I caught 91% of the normal curve. All right, let's do another one. Take a minute and figure out what z-scores bound the middle 86%. What are these z-scores?
7. So in the positive. So we're here in the positive. We have to look in the positive.
No.
No.
Okay, real quick, hey guys. This picture is symmetric, right? Around 0. So if that's negative 1.7, that has to be positive 1.7 because it's bounding the middle. But how can I look that up and verify? Well, what area is below this? 0.91 plus 0.045. So if you look at 0.955, you don't have to do this, but if you look at 0.955,
Oh,
955, it looks like this one's closer. See 1.7 up. But why do that when you know it's going to be symmetric, so it's just a positive? So same thing's going to happen here. If this is negative 1.2, that's going to be positive 1.2 because it's symmetric. Woogie woogie. So let me make sure you guys are doing all right. If there's 86% inside, there's how much total outside? How much total outside? 14. How much on this side? 7. So if you saw somebody doing this problem sitting next to you and they're doing this, 0.07, what do you tell them? 0.07, that's what he just said. There's the answer. What am I doing wrong? I am doing something wrong, so don't. What is 0.07? Is it a z-score? No, it's not a z-score.
No, it's the area.
It's an area. Where are the areas in this chart? So I'm on the wrong side. All right. Yes, so again, remember when I told you z-scores and areas are evil because they look like each other? 0.07 looks like a z-score. We're the humans, though. We know it ain't a z-score.
Negative 1.5.
Let's see. What's the closest to 0.07 I can get?
1.48.
0.07. Which one of these is closer? 694. That's only 6 away, whereas that's 8 away. Can you guys see that?
Yeah.
It's like 694 and 708. All right, this is closer. So what is that? That's going to be negative 1.48. That's cool. Aw. Negative 1.48. So what's this? Positive 1.48. That's crazy. Sure. You got to do 6D before we do that. So that's the one somebody's asked about, or the uniform one, right? So let's do 6D first. You guys heard that too, right? Is it chicken? Rooster? Whatever? Yes? I just need to make sure. So I know I'm not like missing some meds or something. I'm going to turn around one day and say, you guys heard a rooster? No, man. Something wrong with you. I'm like, oh, shit. All right. So this is 6D on the practice test. These are the formulas for the mean and standard deviation of a uniform probability distribution that you do not need for the test, but you need it for this problem, so So students, you got to separate the fact that there are things you need to know and that there are things that I can fit on a test. Just because it doesn't show up on a test doesn't mean it's not important. But oh well, I don't know. We'll never figure that out. So what are A and B?
2 and 8.
Yeah, for this problem, it's 2 and 8. It's going to be how far that range is over. It goes from 2 to 8. So this will be 2 plus 8 divided by 2 is 5. So the mean is 5. And then I just plug it on in here for the standard deviation. So we get 8 minus 2 squared over 12.
1.732.
Yeah, this is 36 divided by 12 square root of 3. 1 point who?
732.
732? So let me say this again. You don't need these formulas for the test. And then some students go, well, why the shit are you making us do it? No, shut up. I'm tired. All right, now on 6E, so that's the mean and standard deviation. That's the standard deviation that works for individuals. 6E, I'm saying, what's the probability, if I take a sample of size 43, what's the probability that the sample mean is from 4.3? 4 to 4.7. So this is uniform, correct? This is a uniform distribution. But so if I ask you up here what's probably that x is between 4.4 and 4.7, it would just be 0.3 divided by 6. It would just be the area of that rectangle. But what's true here? What happens on part E? What does this distribution become? Because 43 is bigger than 30. It becomes normal. So I can use z-scores to do this. That's the power of central limit theorem. It says, yeah, sure, you have formulas and shit, but the minute your sample size is big enough, you can just use z-scores and then all the answers are on the chart. So I got a normal curve. What goes in the middle? 5, because that's the mean. And I want to know 4.4 to 4.7. So now I just make z-scores out of those. Again, why am I allowed to use a normal curve? Because sample size is big enough. Now what am I going to use for the standard deviation though?
Standard deviation divided by.
Yes, the old one divided, yeah, there are 5. The old one divided by square root of 43. I like it. So instead of me just doing this all over again, I already did it once. Let me go ahead and give you the answer key. Looks like we had about a 20-degree swing in temperature in here. No, it's nice for me, but I know you guys are probably chilly. Too bad. I like it. So I think on number 6E, oh shit, I didn't even finish it. Might as well do it. So for the standard deviation, I got 0.264. So I thought I guess I didn't finish it. So let's go ahead and do this right now because I didn't finish that on the key.
Yeah.
So if I want to make both of these into z-scores, I just take 4.4 minus the mean divided by the standard deviation. Why can't I use this standard deviation? Because it only works for individuals. And on part E, I'm talking about groups of 43, so I need to make the standard deviation that works for groups of 43. If you look at it like that, which is the right way to look at it, you'll remember to do it, because it just makes sense. All right, so whatever the hell that is. It's 30 over 13. 2.3. So what is it? 2.27?
Negative.
Yeah, negative. I like it. So that's negative 2.27. I got to make 4.7 into a z-score.